Hello guys, welcome back to Dawn Academy. We're doing math edition this time. Okay, so we're going to be talking about optimization. So let's start off with what is optimization? Optimization is just trying to make the best out of what you have, either the shortest or the longest. So we're going to see that in this problem that it has more than one application. Yeah, so basically you're just trying to optimize. If you still haven't figured that out already, now you have. Okay, so let's start off. This is the homework that we had in class. And yeah. So the first one says, find the minimum distance from the graph of the function y equals the square root of x to the point 3/2, 0. So in this problem, we're going to predict that we have a graph. Okay, let's draw that graph out. So here's our coordinate plane. And our graph is going to look something like this. Square root of 1 is 1, square root of 2 is something over here, square root of 3 is something over here, square root of 4 is 2. So we're going to have something like this, something like that. Yeah, so that's going to be our square root graph. This is going to be the square root of x. F equals square root of x. Oh, y. No! Okay. I meant y equals square root of x, so y equals square root of x. There we go. Okay, so we're gonna try to find, and let's put down the point 3/2, which is 1.50. So we have 1.5 over here, 0. It's gonna be our point P, let's call it. So right now, what we're trying to see is how can we get from P to this line in the shortest way possible. We can go from P to this point over here. Well, that's quite a long distance. We can go from P to this point over here, and that's a bit shorter. Is this shorter? Potentially. Is this shorter? Potentially. So we're trying to find the line between P and y square root of x. We're trying to find which one of these is the shortest. So that's what we mean by what is the minimum distance we have. So that's what we're going to be trying to find. And in order to do this, we have to start by thinking, what formulas can I use? What formulas did the question tell me about? Well, we have this one right here. It's number 1 formula. And that's basically it. And they're asking us for the distance. So we can figure out that we're going to probably be using the distance formula. Distance formula. So in order to find the distance formula, we need a distance between this point and one of these random points. We don't know which one, but one of them. So a point on this line is going to have the x-coordinate x. So we're trying to find random point here. Random point on square root of x graph. So it's going to have an x of x, right? And the y is going to be whatever the square root of x is. So the coordinates of this random point are going to be this. And all the points of this graph satisfy these coordinates. So that is why we're using them. Now, we're going to use our distance formula. So we're going to say the distance is equal to the square root of, we're trying to find the distance between this point. So we're going to say the distance between 3/2 minus x, because these are x values, plus, what's the y coordinate? 0. 0 minus the x coordinate, which is, the y coordinate, sorry. So basically here, let me just put this in a classic formula way. We're going to go x1 minus x2 squared plus y1 minus y2 squared. This is going to be our distance formula. Distance. Okay. Now, what we want to find is we have our formula and we have all the things in it, and we're going to try to find the minimum. So what we're going to do is we are going to set this to 0. Oh, no, we're not. That is my bad, guys. Okay, we can't set this directly to 0 because look how complicated that equation is. It's quite a complicated equation. So our solution to this is going to be taking our little calculator right here. Oh, there's stuff in here. Okay. And we're going to put this equation in it. Now, let's see. Square root. Where's the square root? Square root of 1.5 minus x. Oh, I didn't put parentheses. 1.5 minus x all squared plus parentheses 0 minus square root of x close parentheses all squared. And we're going to try to graph the derivative because in the classic way, we would try to find the derivative of this and then we would zero it and we could get our stationary points. And then we would see if it's a minimum or if it's a maximum. And we would take the local minimum. But we can't do that. And we don't have a limitation on what these could be. So what we're going to do is we're going to graph it. And now we're going to graph the derivative as well. We have to do math. Where's math? Math. We go derivative. We're going to go vars, y vars function, y1, x for all x, graph. Oh, okay. So there's our function. Did I type that in right? Yeah, seems about right to me. Graph. So now we're going to look at the 0 of our function. So let's go to trace. We're going to find our 0. We want to find the left bound. So we're going to take our right bound. And we have the 0 is 1. So our point is writing the wrong thing. The point that is the minimum distance is 1, 0. Now, since we have our point, they're not asking us for a point. They're asking us to find the minimum distance. So we actually do need to put this point into the formula. So we're going to get 3 over 2 minus 1 squared plus 0 minus square root of 1 squared. And we're going to get 1.5 minus 1 is 0.5. So we're going to get 1 over 2 squared plus 1. 1 squared is 1. And we're going to square root that. And we're going to get, these are going to cancel. So we're going to get 1/2. So we can say that the shortest, oh, no, it's not 1/2. I forgot about this one over here. It's going to be 1/2. We're going to have 1 over 4 plus 1, which we're going to get, let's see, 1 is 4 over 4. 4 plus 1 is 5. We're going to get 5 over 4, square root of 5 over 4. If we simplify that, we can get square root of 5 over 2. So we can say the shortest distance is square root of 5 over 2 units. So we can say it's going to be 0. It's 1, 0. So, I meant 0, 1. No, 1, 0, yeah. Okay, so the shortest distance is going to be that far. And yeah, that is the answer to that question. Now, moving on, the shape in figure... Oh, I should probably include that shape. 1 moment. Okay, so we have this figure, and the question is telling us that we have this rectangle right over here. We have a rectangle, and on the side, we have 2 semicircles. So kind of it's giving a football field. And it tells us that this whole thing of the rectangle is 100 centimeters squared. That's the area of it. And it's telling us to find the minimum perimeter of the entire figure. So this plus this plus this plus this. And we have to find the coordinate of the value of x that makes this come true. So we want to find the shortest length of the rectangle to make this whole thing have the smallest perimeter. So what are we going to start with? We have to go back to our first question. What are the formulas we are going to be using? So we already have one formula, which is that the area of the rectangle is going to be length times width. Well, let's use these using x here. So we're going to say x times length equals area. And we're going to say x times length equals 100, because that's what we know here. And we know that this is a circle right here. This is a circle almost. And so I drew kind of like a continuation of a circle. And that reminded me of how this is the radius of the circle. And this is also the radius of the circle. So this AD, this L is also equal to the diameter of the circle, which is 2 times the radius. So when we want to find the circumference of a circle, if we want to find this whole thing out, what we would have to do is use 2 pi r. So let me just clear that out for you. Here, circumference equals 2 pi r. And this is length times width. Oh, well, that's for the area, actually. If you want to talk about perimeter, we're going to have to do 2L plus 2W. Okay, so let's say let's talk about the perimeter for a moment. Perimeter. So we're going to start off with here. We know we have 1x. We have 2 x's. So we have 2x. And over here, okay, yeah, 2x. Over here we have half a circle. Over here we have half a circle. So 2 halves of a circle are going to make a whole circle. Say plus 2 pi r. And it's going to give us p, which is the perimeter. And we know from here that L is equal to 2 r's. Because this is a r and this is a L. So 1 r is equal to 2 L. So that means we can replace r with L, which we can replace with x. So, okay, let's put this in terms of x first. XL equals 100. If we want to know what L is equal to 100 over x. And if L is equal to 2r, that means 100x is equal to 2r. That means that 2rx is equal to 100, which means that r is equal to 100 over 2x. So let's just throw that in here. 2x plus 2 pi 100 over 2x equals p. Now, if we pluck those out, get 2x plus 100 pi over x equals p. Now, we have our perimeter formula and we use all the formulas to get there. Now we need to find the minimum. So we're going to take this and we are going to derive it. We don't need to use a calculator here because we can derive this pretty easily. Using the rules of derivatives, we can just know that it's that if we want to do p prime of x, we're going to get 2 minus 100 pi over x squared. And from that, we can set this to 0 and find the minimum. So we're going to get 2 minus 100 pi over x squared minus 2 equals, oh, let's not do that. Let's do 100 pi over x squared equals 2. And we can cross multiply and we're going to get 2x squared equals 100 pi. Right now, guys, I'm just solving. So if you're not with me, just these calculations are quite simple. If you want to just do them on your own, you get 100 pi over 2. So we're going to get x squared is going to be 50 pi. Now, finally, final step, we're going to get, if we square root them both, we're going to get x equals square root of 50 pi. And that is our answer. We can put this on the calculator And that was Ms. Brooks' email for the seniors. Put this on the calculator and we can get square root of 50 by 12.5 equals 12.5 centimeters. And that is the smallest value of x. That's it for today. Thank you so much for listening in. If you have any questions, do let me know. Goodbye.